The next speaker is Olivier Blais. He is co-founder and head of design science in Moon AI. For today, he presents topic "What about AI for business?" Good luck. Olivier, are you ready?
Yes, I'm ready. Can you hear me?
Yes.
Excellent. So I'll share my screen.
Okay.
Yes. Perfect. Now can you see my screen?
Yes.
Excellent. Thank you very much. Thank you everybody for being here. I'm very glad to be talking about this. Is basically my favorite subject. It's how to make sure that we're able to adopt artificial intelligence in organizations, because it's so easy to get lost and build stuff that is not useful for anybody. So this is why here I'm going to talk about AI adoption, but really correlated with the delivery of a successful solution. So here, a little bit about myself. So my primary role is head of decision science for Move AI. So Move AI, we're a consulting company based in Quebec, Canada. And I'm also a chief product officer of a tool that's called Snitch AI. So we are an AI system quality evaluation tool. I'm also editor of the quality evaluation guidelines for AI systems as part of the ISO standards. So I'm currently making sure that we have the proper guidelines to evaluate the quality of an AI system. This is pretty important, and this is something that's really important to me. So here I'll start by with this very generic statement, because I think this is important. I saw that about 2 years ago, we were already talking about, so Gartner was already talking about this, but I think this is still very relevant. And it spoke to me, like this drove me into this mindset of, whoa, okay, we need to do something about adoption. So what we're saying here is that 85% of AI projects will not work. And I can be, so this one is really precise towards like the quality of the machine learning. But here, I think that the most generic statement that I'm sure every professional will agree upon is that most machine learning and AI solution will not deliver the appropriate results and will not generate business value. Okay, so this is essentially what I realized, and many organizations realized along the way. So what can we do to be able to get there and be one of the successful projects? So what I'll do, I'll walk us through the process. We'll talk about different dimensions of a project, and then we'll so I'll give you some tips and tricks on how we're able to make a difference and have a successful project for once. So first of all, let's look at the full AI journey map. I think this is a good start, because it really depends where you are in terms of maturity as an organization to decide if AI is first AI the right next step, and B, what you need to overcome in order to have a solution that's going to work in the long run. So here are 5 different stages, and in fact, there's even the stage 0. You don't care, and you're skeptic about using data for day-to-day business. Believe it or not, but there will be people who completely lacks maturity in data science because they're non-believer that the data is useful for their activities. But let's be a little bit more optimistic and positive about this. The first stage in terms of maturity will be to capture data. So we know that some companies, they're not necessarily very advanced, but at least they're starting to capture data, they're centralizing data, and sometime when when all hell break loose, then they're going back in their data infrastructures and they're mining a little bit the data just to understand what went wrong. Okay, so this here, there will be a lot of business that are at that stage. I've been surprised when I started my like Move AI, because initially I thought everybody want to do AI. They're very advanced in the maturity landscape, but a lot of people, they say, you know what, I don't have a lot of data, so they're not even at one. So they're saying, you know what, I don't have a lot of data, but can we do something with like data that is available at the like externally? So usually when you hear that, you understand that, okay, they're probably a little bit like immature. So so here, this is something that's important. So when that happens, you really need to talk about data hygiene, data best practices, making sure that they have infrastructure, because the worst that you could do is you start creating a project with like external data because they don't necessarily have a strong database or like a stable database. And then as soon as you deploy the solution, things changes because they don't capture the data, or they change the way they envision it, and so it doesn't work. Or even worse, how can someone leverage the output of an AI system if they don't believe in the data and they don't necessarily have the analytical capabilities to take the output and make something good with it? Okay. The next step usually is going to mine the data, being able to visualize the data, and analyze a little bit. So what's going on? What happened in the past? And this here, so what it means that they're starting to build trust around the data sources and the database that they have internally. So this is a very good news. So if they don't reach step 2, what it means is that they have data, but do they trust the data that they have? The answer is probably no, because they're not even willing to start building visualization and identifying trends that can help them understand a little bit further their business and identify a winning strategy. So here, but even there, this is great. So you start from a non-believer to a data a company with data enabled company, and now you have the ability to mine the data and start do some smart decision based on the data. But there's even when you're at that stage, there will be a big gap between step 2 and step 3. Here we're calling it a chasm, but what it really is, so it's a mix of several different things that will prevent companies from going to from step 2 to step 3. So first of all, lack of expertise. So it's one thing to be able to build visualization and mine data. So a little bit of SQL. Everybody's proficient or have some proficiency with Excel, with PowerPoint. So you're able to build to build good charts, good presentation, storytelling. So this is something that you can do. But when comes the time to build some statistical models, it's a big gap in terms of capabilities. And usually people are not necessarily have a lack the readiness of that type of expertise to go forward with predictive analytics. So there's that. Also, the another element that we need to take into consideration is the transformative aspect of predictive analytics. You're trying to predict the future. You're trying to like automate decision making. So you're trying to replace something that is really important to a human, take a decision, by a machine learning algorithm. And this is very difficult for people to go and to build trust around that fact. Why should they trust an algorithm that they don't necessarily understand? How can an algorithm beat the human? And sometimes you will see some very unfair games and people trying to break the machine learning. It just demonstrates that a transformation needs a lot of change management. And here, this is something that often we lack when we're trying to go from step 2 to step 3. And at the end, to be able to start like predicting, building predictive analytics, there's also an aspect that's really important, and it's the fact that this is not normal to predict the future. Like even just saying predicting the future, I sound like an oracle, or like we think about the crystal balls, the oracles like tarot and those type of techniques, and this is just not natural. And my data science mindset, think about it as like the prior of the human prior is to not trust that we're able to predict the future, because this is the norm. We're not used to that. So this is why here it's particularly hard to get to step 3. But then step 3 is just the beginning of the journey. So step 3 is it's really minimal. It's being able to predict what's going to happen. While step 4, it's to say, what, based on my predictions, here's the best solution to answer the end user's needs. And then step 5, it's to go even forward and say, what, not only do I predict well the future, I'm able to identify the best solution and I'll implement it automatically. So here, I'll give you a concrete example. Let's say you're trying to forecast demand forecasting in the retail world. So if you are a retail company, predicting demand is really important. So step 1 is to acquire information about the retailers, the retailers' sales. Okay, so sales data. Step 2 will be to analyze the retailers and find some trends, find some seasonalities, all that good stuff that will give a good starting point. And then step 3, now you fall into automation. So the step 3 would be try to predict for the next month what's going to be the demand for products, by products. That's it. The step 4, you go further than that. So you will try to say, what, based on the demand, I will suggest the number of units that I can produce in my supply chain to meet the demand. So you don't necessarily need the human to make these assumptions. So we can, with optimization tools, we can start to analyze the demand that we predict, and then go back in the process, and then suggest the right quantities to the supply chain. Then step 5, you don't even need someone in the middle. So the full chain of value can be automated without any supervision. So here's the depth to which you can go with machine learning. And this can be really radical. So it really depends where the company is in terms of maturity, because the step 5 is like down the road, and maybe people will not be ready for this at all. So here, this is the big gap. It's that most companies, and you can validate, but it really depends in the industry. But for instance, if you look at the industrial companies, the manufacturing companies, most B2B companies will sit between 1 and 2. And then when you start going in B2C, you'll see something between 1.5 and 2.5, let's say. But you will rarely see people who are comfortably in step 3 and up. Okay, this is just so rare. Those are the real success stories that you hear. But there's a big gap in there because you need to make them go further up. So here, how do you do that? So first, you think about impact and complexity. So the impact is the impact of what you're going to do. So is the transformation that is suggesting appealing enough for the companies to go forward and say, you know what, yes, I want to do it. And then there's complexity on the other end. So the complexity, here are the four most important dimensions to think about complexity of an AI project. First, you have the data. Is the data, do you have enough? Is it enough features, enough quantity of data? So this is what you need to think about. This is one of the biggest barrier to entry. It's the access to clean data. Then there's also the task. What are you trying to achieve with the machine learning model? So a rule of thumb for your information that I often use, and it's almost true. It's true almost all the time. If a human is able to make a prediction based on the available data, usually you will be able to some extent to generate this prediction with a machine learning model. But if a human is not able to do it, there are different reasons why it might not work. Maybe because the task it's too demanding. Maybe it's just not feasible. Let's say you're trying to predict the lottery winning combination. Like, it's crazy, but sometimes we might be tempted to try to automate stuff that is just not automatable. This is possible. Or usually what I would see is that the project is too ambitious. It's too broad. Like, I want to automate my production. Yes, but yeah, what do you exactly want to do? This is too broad. So maybe you want to focus on being able to prioritize the different work orders, to automate some operations, quality assessment. There are various different steps that will require its own project. Then another risk is around the adoption of the solution. Adoption, again, I'm talking about adoption a lot, but this is a key. Here, it will really be about the criticality of the system that you're trying to implement. So if a system is really critical to the business, you will get some trouble with adoption. So, you'll be double check, triple check. It might be a very difficult run to be able to have something that works and something that is used, because it's critical. And then finally, the integration. You might have the best model in town, but if the model resides in a Jupyter notebook and the user is using SAP, you're far from what the user is going to use. And an SAP integration might take as much time as building an AI system just to integrate. So you need to think about that very early in the process. So here, what you do, so you map it. I'm a data scientist, I'm a geek. So these type of graph, it's two-dimensional, it's a scatter plot. So this speaks to me, but this is really important to be able to compare the impact with complexity of what you're trying to achieve. And this way, you're able to take the right decision on the best first project that you want to undertake. And usually, what I do when we're talking with customers and this is their first projects, is that we'll look at complexity first. Okay, you might be tempted to work on the big hitter, the big bets, it's called here. But complexity might be a bigger hurdle for you at the beginning. So what you'd like to do is to look at the lowest complexity and then find the highest impact in this range. So this gives you a little bit more room for mistakes and iterations, because complexity will be lower. So you'll be able to deploy something that still makes sense. While like a very high complexity project might take years, and when it's the first project, it seems like a mirage. It seems like something that never will be delivered in production. So now that we found the right project, and here I skipped voluntarily the discussion about data, and here what I'll say is, again, data is very key. So please take the appropriate time to review the data. The only thing though that you need to be careful is to do the data analysis in an iterative fashion, okay? You don't want to say, you know what, to do this project, you need to spend a year working on the data. We were talking like about the big data initiative like 10 years ago. These often don't work because working on data is a mean to an end. So this is not a project by itself. It should not be a project by itself. It should be a step in the project. And here, what you want to do, it's if we come back, let's say here you have this project. So what's the data that you need to acquire to be able to deliver this one? And then you work on data availability and data stability as part of this project. And then when comes the time to work on another project, you complement the database that you would create. So this is the best way to be able to get the result that you want. So let's say here you have the project, you have the data. Now is the time to build the model. So here, usually this is the best part for the machine learning. It's to test different algorithms and configuration. So here, please listen carefully. This is just a step in a process, okay? If you have a model, but you don't have any system, this is garbage. You need to think about it as like, this is one step. I'm going to build a model that works, but then after that, you select the model, you validate the model quality, and you deploy this solution, okay? So here I want to highlight the two last steps because those are very important. When you build a model, you need to validate the model quality, and this is way more than just say, you know what, this is 92% accurate, so do I have the green light? This is more than that. So you need to take that into consideration. We need to be able to drill down in the model quality and say, you know what, this is great. I understand the different features and the impact of the feature on the model. My performance is as good for the main use cases. I'm able to control the data drift, so that I will not be surprised by data that doesn't look that doesn't look as the data that I use for training, etc. So this can be really demanding, and you need to be extra careful when you validate the model quality, because it's more often than not the far west, I feel. So as long as the data scientist is able to convince the business users that the accuracy or the AUC metric is good enough, then we could go forward blindly. So this is something we should never we should never do. So we need to spend the appropriate amount of time working on this. And then we're talking about deployment. So the deployment is also something that's really important. And actually, I'll talk about it right now. So here, this is usually how MoveAI work on project. This is how I used to work on project in my previous experience. So first, you have the project liftoff. So you identify like the project, the vision, the objective, everything, and then after that, you work on. You could call it a prototype, but we like to call it a minimum viable model. So here, what you want to do, you want to do a end-to-end as quickly as possible. So you build an end-to-end. It's not going to be perfect. You might want to test maybe one or two algorithm families. So you might want to have something very simple. Then maybe, I don't know, a XGBoost, and then maybe you want to deal with deep learning, like LSTM if it's for time series. Okay, so you then select the right one, but you then build the full end-to-end, and you present this end-to-end to the customer. So the goal here is to demonstrate that the solution works, and you're able to get, you're not going to get the good performance that you're looking for, but you're getting there. And you want to demonstrate that machine learning is the right option to tackle this problem. So once you've demonstrated that, the goal here is simply to enhance what you have. So like hyperparameter search, maybe find new features if necessary. But the model and like the training phase, it's already taken care of. So you can just continue and fall into the MVP. So MVP, you enhance the model, but then we're really talking about a product. So you're talking about all the code that need to live for a solution that you need to create. And here, just a cue for the MVP, the data scientist will not be the main actor. Here, you're going to talk about the ML developers. You're going to talk about the software developers. There's a lot of code that you need to have, and you need to have proper code in there. It needs to be not only a model of good quality, but a software solution of good quality as well, if you want it to be a success. So then when you have your MVP, then we're working on our goal is to bring it to the people. Get out of the building with the solution, make it tested by the end users. So you'll get some iteration of beta testing. The goal here is to make sure that the end users are pleased with the results. They're understanding the machine learning behind the scene, and they're willing to use it to take decisions. Then as soon as the end users trust what you have, and the model and the solution are stable enough, then you work on the final optimization to then have the solution deployed in the right environment. So here, when I talked about the AI code versus the rest of the solution, this is what I mean here. And this comes from Google. So Google, what they say is that often we will focus on the model, but this is a tiny bit of the full solution. So here, okay, what about the infrastructures? What about the monitoring? This is important to be able to monitor the solution. You can not just have faith and hope that it will work fine. You need to monitor the quality assurance, the resource management. Do you have so is your VM robust enough? Do you have redundancies? So there's a lot of things to take into account to have a solution that works in the long run. And those are all things that you need to take into consideration. And you see here, those are more software driven than AI driven. And this is why you also need to take into consideration that you need this skill set on board. So here, when comes the time to deploy, we'll talk. And I like the previous presentation, because the presenter talked about MLOps, for instance. So here, first you have the ML, and in the ML, usually what you will do is, okay, I think we all know the drill. We develop a model, we validate against test data. So there's already, it's already known. But usually there will be some need for troubleshooting. And this is why we have a lot of open source packages and libraries that are existing. And this is great. But then when you build your model, then you fall into the dev mode. What we just talked about, it's all the other tile, okay, of your model. So you need to create, and then you need to package everything. When we talk about continuous deployment, continuous integration, I don't know if you heard those terms. This is because once you have built your model, you need to refresh it often. And we'll talk about it right after. But this can be problematic when you don't have the right development approach. So here, what you'd like to have is you'd like to have a smooth transition from ML to the operation, and then so it's the ability to package well your code, and so you deploy your code, you deploy your model, you deploy your code, you integrate it into the production environment, and then it's operational. Okay, but that needs to be smooth, and that needs to be verified on various different levels to avoid overfitting, to avoid any 404 errors, any type of errors that might cause trouble to your model. And then finally, the operations, it's all about the managing the different release and monitoring that things go smoothly. And this here, we often don't spend enough time in the monitoring phase and the operations phase. So we need to spend probably around 25% of the project price, the project cost, in this space. So when it's operational, everything that you need to do to have a model that keeps getting better and better. So here, it's a little bit what I'd like to present. So if you look at performance over time, so first here I'm showing so it's going to be a slow curve, especially when you work with the MVM that I talked about before. And if you work in Agile, what I recommend, by the way, it will take time to get good results. But then when you have good results, so the first gap here, what you see is in the first iteration, it's because you will do the beta testing. So first you have the slow curve because of the MVM and the ML process. Then you think you have good performance, boom, you fall into user feedback. Then you realize that it was a lot more complex than you anticipated. So you fix things, you then redeploy it. And then here, this is what's going to happen. Okay, it's very, very common. So your model is good for some time, and then boom, it falls again. It's something we call degradation. Degradation, it's not, sometimes we say model degradation, but honestly, this is a lot more related to the data. So people change, process changes, everything changes with time. So we need to be to validate we call that a concept drift or data drift. So when the data changes, it might be good, it might be okay if your model is robust enough. But if your model changes, if your data changes and your model is not able to make prediction, so usually it will degrade. Sometimes it can be drastically, sometimes it can be slowly over time. So here you need to monitor that, and you need to retrain, redeploy. This is why I talked before about the continuous integration, continuous deployment. It's because you need to have a solution in place that will be able to flag when there are problems, when there are degradations happening, retraining, redeploying, and this is pretty critical to be able to have a mechanism in place, or at least to be able to do it manually, but you need to do it. Otherwise, you will have problem. And by the way, I don't know how well you understand machine learning, but sometimes some people, they have the tendency to think that machine learning is learning continuously. Although it exists, like reinforcement learning, active learning, online learning, there are some tools that make it happen, but most models and most approaches right now are learning every time you train them. So you train them with, I don't know, 3 years of data, then you're making predictions based on a static model. Then after that, when the predictions are not good anymore, you retrain it, then it refreshes the model, and you're good to go for another while. So this is how it usually works, and this is why I'm talking about the retraining and the evolution strategy being so critical. It's to avoid like a set it and forget it, and then after that the model is not good anymore, but you flag it only when things go too bad and you don't have an easy way to fix the model up. So that's it for me. Thank you very much for your time. I was wondering if you had any questions.